Hello my precious friends, I really hope that you're doing great. Welcome to our today's class. It's our fourth lesson on a given Form 2 mathematics topic called equations of a straight line. So we are looking at our second example, which is a past Kcse equation tested in 2015, paper 1 question number 21. So part A of the question reads that a straight line L1 whose equation is 3y minus 2x is equals negative 2 meets the x-axis at point R. Determine the coordinates of the point R. So the first thing I'm going to do is to sketch the given information. So of course I'm having the y-axis and of course the x-axis, because I'm told that this particular line is cutting the x-axis at the point R. That simply means that the point R is representing what we call the x-intercept. So a straight line, it is intersecting the x-axis at the point R. So this is what we are calling our point R. So this is the line that we are calling line L1. A straight line L1 whose equation is, so the equation of this line I'm given as 3y, then of course minus 2x, of course is equals to negative 2. It is meeting the x-axis at the point R. So you can see the point of intersection of L1 and the x-axis is the point R. Determine the coordinates of the point R. Now, we know that the point of intersection of any given line with the x-axis is representing what we call the x-intercept. Therefore, R is representing the x-intercept. So we are simply going to say that at point R, at the point R, which of course is the x-intercept, which is the x-intercept, at that particular point, the y-coordinate must be equal to 0. So any coordinate of y along the x-axis will always be equal to 0. Therefore, substituting y is equals to 0 in the equation for the line L1, I'm going to have the line L1 was 3y, then of course minus 2x. This was equivalent to negative 2. So substituting y being equal to 0 in the given equation, I'll have 3, then into bracket, my coordinate of y will be 0. That is along the x-axis, then minus 2x being equal to negative 2. So 3 by 0, I'll get 0. Then of course minus 2x is equals to negative 2, which simply implies that negative 2x is equal to negative 2. Dividing through by negative 2, also the right hand side, I divide through by negative 2. It simply implies that the coordinate of x at the point R will be equivalent to negative divided by negative, you'll get a positive. 2 divided by 2, you'll get a positive 1. Therefore, it means that the coordinates for our point R, of course, any given point, its coordinate must be given in the form x, then comma y. So that means that similarly point R, which is in 2 dimensions, my x coordinate is 1, whereas the y coordinate, of course, is 0. So any given point along the x-axis, its y coordinate will always be equal to 0. So remember, the question wanted us to determine the coordinates of R. Therefore, R is actually 1, then comma 0. So that is the solution. Then we check part B of the question, whereby we are being told that a second line L2 is perpendicular to L1 at R. So we have another line L2 which is perpendicular to the initial line L1 through the point R. So this particular line L2 is passing through point R. Then through that particular point R, the angle is 90 degrees because these two are perpendicular to each other. So this angle must be 90. So this is the line L2. Then it is perpendicular to L1 at the same point R. Now, I'm being told to determine, find the equation of L2 in the form y is equals mx plus c, where m and c are constants. Now, I'm told that the two lines are perpendicular. We know that for any given pair of perpendicular lines, the product of their gradients must give us a negative 1. So we'll say, since, I'm simply going to say, since L1, since the line L1 is actually perpendicular, since L1 is perpendicular to the line L2, it follows that the gradient, the product of their gradients must give us -1. So the gradient of L1 multiplied by the gradient of L2 multiplied by the gradient of L2, it must give me -1. So remember, for any given pairs of perpendicular lines, if you take M1 multiplied by M2, must give you -1, where M1 is representing the gradient of the first line and M2 is representing the gradient of the second line. So I need to have the gradient of the first line so that I can use it to find the gradient of the second line. Now remember, for the first line, I already we were given the equation, which was 3y minus 2x is equals to -2. So the equation was 3y, then of course minus 2x. This was equal to -2. This was the equation for the line L1. So if I want to find its gradient, I'll be forced to convert it in the form y is equals to mx, then of course plus c, which is the general form of the equation of a straight line. For me to achieve that, I'll start by taking -2x towards the right hand side of this equation, so that I end up with 3y being equivalent to 2x, then of course minus 2. If I want it in the form y is equals mx plus c, I'll divide through by 3. I also divide through by 3 divided by 3, so that 3 and 3 can cancel out, so that I end up with y being equal to a positive 2 over 3x, then of course minus 2 over 3. Now clearly it is in the form of y is equals to mx, then of course plus c. And by direct comparison, remember m usually represents the gradient of the line, so clearly the gradient for the first line is a positive 2 over 3. Now, because the first line and the second line are perpendicular, I can use the gradient of the first line to find the gradient of the second line. Remember that for any given pair of perpendicular lines, m1 multiplied by m2 should give you -1. Therefore, my m1 will be the gradient of the first line, which is positive 2 over 3. So I'll have 2 over 3, then multiplied by the gradient of the second line, m2, which is perpendicular to L1, must give me -1. So to get the value of m2, I'll multiply through with the reciprocal. Of course, the reciprocal will be 3 over 2. So multiply by 3 over 2. Also, the right hand side multiplied by 3 over 2. So remember, 2 and 2 will cancel out, 3 and 3 will cancel out, so that the gradient for the line, the second line L2, which of course is m2, will be given by -3, then of course over 2. Remember, the aim is to find the equation. To get the equation, you need the gradient and at least 1 point. I was told that L1 and L2, that is L2 is perpendicular to L1 at point R. But remember, we already have the coordinates for point R, which is 1, 0. So L1 and L2, clearly you can see that they are sharing this particular point R. Now, we were told that point R, we had already found the coordinates for point R to be 1, 0. So these coordinates are 1, then comma 0. So I'll use the second gradient, which is the gradient, this is the gradient for the line L2. Then L2 is also passing through 1, 0. So I'll pick another point, a general point x, y, so that I can use it with the first coordinate of R to find the equation in the general form. So I'll let this to be my x1, then this to be x. That is the other one to be x1. Then of course the second one is supposed to be y1, that is working with the first coordinate. So if this is x1, this is y1, then I'll let this to be x2, then this to be y2. We know that the gradient of any given straight line, so the gradient must give us the change in y over change in x, which is y2 minus y1, divided by the change in x is x2 minus x1. So the gradient for the line L2, we have already found it to be -3 over 2. So that implies that -3 over 2 must be equal to y2 minus y1. My y2 is actually y, using the general point selected. Then my y1, of course, is 0. Then divided by my x2 is the coordinate x. Then minus x1 of course is positive 1. Now if I do cross multiplication, I'm going to get the following. So this is what I'm going to end up with. So I'll have this one can be written as negative 3 over 2, then of course being equal to y minus 0. I'll simply remain with positive y, then divided by x minus 1. On doing cross multiplication, this one will move up, then of course this one will multiply with that. So I'll end up with negative 3, then into bracket x minus 1 being equal to 2 multiplied by y. I'll simply get positive 2y. If I open bracket, I'll have negative 3x, then of course negative will give me positive 3 being equal to 2y, which can be rewritten as 2y is equals to negative 3x, then of course plus 3. I was told to express my equation in the general form, which is y is equals mx plus c. For me to achieve that, I'll divide through by 2. I also divide through by 2, divide through by 2. So that 2 and 2 can cancel out. So the equation will be y is equals to negative 3 over 2x, then of course plus 3 over 2. So clearly it is in the required form of y is equals to mx plus c. So this is the equation for the line L2. Let me just label it on my diagram. So the equation for L2 is y is equals to negative 3 over 2x, then of course plus 3 over 2, plus 3 over 2. So we've answered part B of the question. Then we move to part C, Roman 1 of the question, whereby we are told that a third line L3 passes through the point negative 4, 1 and is parallel to L1. Remember, parallel lines usually have equal gradient. So I'm told that it is parallel to L1. So it means that this third line, it will be parallel to L1. So that means it is passing through, it is moving this way, such that this third line is actually parallel to the initial line. So remember, this is our line L3. It is parallel to our line L1. So we know that for any parallel lines, any given pair of parallel lines, you will always have the same gradient. So our first aim is to find the gradient for L1 so that it will be equal to the gradient for L3. So we'll say that since L1, since the line that is L3, we are told that it is parallel to the line L1, it follows that the gradient for L3, it must be equal to the gradient for L1. So parallel lines will always have equal gradients. Now let me check whether we have the gradient for L1. So actually the line L1, we were given its equation. So we can use this equation to actually find the gradient. So the equation was 3y. The equation for L1 was 3y. Then of course minus 2x. So this was equivalent to negative 2. So that is 3y minus 2x is equals negative 2. To find the gradient, we'll be forced to express in the form y is equals to mx plus c. To achieve that, I'll take this towards the right hand side so that I'm having 3y being equal to, so 3y will be equal to positive 2x, then of course minus 2. So positive 2x, then minus 2. Then I'll divide through by 3, divide through by 3, divide through by 3, so that 3 and 3 can cancel out. So y is equals to a positive 2 over 3x, then of course minus 2 over 3. So clearly it is in the form y is equals to mx, then of course plus c. So clearly you can see that the gradient for L1, that is the initial line, was actually positive 2 over 3. So because L1 is parallel to L3, it also implies that the gradient for L3 will still be 2 over 3. So we'll say that gradient for L3, the gradient L3 must be equal to the gradient L2, the gradient of L1, since the two are parallel, which is equal to positive 2 over 3, positive 2 over 3. Now I have the gradient. I also have the, that is the given point. So it simply means that using the point given, which is negative 4, then comma positive 1. Then of course I'll pick a general point, x, y, so that I can use it to find the equation in the required form. Of course I'll let this to be my x1, then this to be y1, then this to be x2, then this to be y2. So the equation will take the form. We know that the gradient of any given straight line must be given by change in y, which is y2, minus y1 over change in x, which is x2 minus x1. So if I substitute, the gradient is 2 over 3. So I'll end up with 2 over 3 being equal to my y2, of course, is y, then minus my y1 is positive 1, then divided by my x2, of course, is x, then divided, that is minus my x1, of course, is negative 4. So this can be rewritten as the following. So of course this will be, so I'm going to end up with 2 over 3. So I'll have 2 over 3 being equal to y minus 1, then divided by x, of course, minus minus will give me a positive 4. Then of course I'll do cross multiplication. This one will multiply with 2, then 3 will multiply with that. So I'm going to end up with 2, then of course into bracket x plus 4 being equal to 3 into bracket y minus 1. On opening the bracket, I'll get positive 2x, then plus 2 by 4, I'll get positive 8, being equal to 3y, then of course minus 3. So if I take 3 towards the left hand side, I'll have 2x, then of course plus 8, then the 3 will be positive, is equals to 3y. So this is 2x, then of course plus, this will give me 11, that is 8 plus 3, which is equal to 3y. So this can be rewritten as 3y being equal to 2x, then of course plus 11. So to convert it in the form of y is equals mx plus c, I'll divide through by 3 so that I can leave y being alone. So 3 and 3 will cancel out. So the required equation is y is equals to 2 over 3x, 2 over 3x, then of course plus 11 over 3. So this is the equation for the line L3 in the form y is equals to mx plus c. So this is the equation for the line L3 that is on the diagram. Then we'll move to part C, Roman 2 of the question. So in Roman 2, I'm being told to find the coordinates of point S at which L3 and L2 intersect. So it means there is a point of intersection between L2 and L3. Clearly you can see that this is the point that you are calling the point S. So they want us to find the coordinates of this particular point of intersection of L2 and L3. So I'll simply use the equations for L2 and the equation for the L3. So the equation for L2 was actually the following. We had already computed it in that is part B of the question. We were told to find the equation for L2. The equation for L2 was y is equals to, so this was y is equals to negative 3 over 2. The equation was y is equals to negative 3 over 2x, negative 3 over 2x, then plus 1 over 3. So we are going to add plus 3 over 2. Let me just verify. The equation for L2, negative 3 over 2x plus 3 over 2, plus 3 over 2. So I want to use the elimination method. For me to achieve that, I'll do away with the fractions. So I'll just multiply through with the LCM so that I do away with the fractions. So LCM is 2. So by 2, then by 2. So I'm going to end up with 2y being equal to 2 and 2 will cancel out so that I remain with negative 3x. Also 2 and 2 will cancel out, so this will be plus 3. So if I rearrange, I'll end up with 3x, then of course plus 2y being equal to 3. I'll label this as my first equation. So it was L2 and L3 intersecting. I also need the equation for the line L3, of course, which we have already computed in part C, Roman 1. The question for L3 was y is equals to 2 over 3x. So y is equals to 2 over 3x, then of course plus 11 over 3, plus 11 over 3. Again, I want to do away with the fraction, so I'll multiply through the LCM, of course, which is 3. So I'll make this a fraction. I'll multiply through the LCM by 3, by 3, by 3. Of course, the 3 and 3 will cancel out, so that I'm gonna remain with 3y being equal to, this will be 2x, then of course plus 11. On rearranging, I'm going to have negative 2x, then of course plus 3y being equal to 11. Remember, I'm rearranging so that I can easily work it out using elimination method. So this is equation Roman 2. Now, using elimination method, I'm going to have the following. So, of course, I'll pick my first equation, which was 3x. So, equation Roman 1 is 3x, then, of course, plus 2y being equal to 3. Then the second equation is negative 2x, then plus 3y is equals to positive 11. So, to eliminate, I want to eliminate y. For me to eliminate y, I'll just cross multiply. 3 will multiply the first equation, then 2 will multiply the second equation. I just multiply with the coefficients. I reverse the coefficients of the equations. So 3 multiplied by 3, I'll get positive 9x, then plus 3 multiplied by 2, I'll get positive 6y being equal to 3 by 3, I'll get 9. Then 2 by negative 2, I'll get negative 4x, then plus 2 by 3, I'll get 6y being equal to 2 by 11, I'll get positive 22. Then I'll subtract these two equations. So I'll end up with 9x. Then we have this minus here, minus. Then of course minus 4x. Then of course here I'll have positive 6y. Then minus this minus here, positive 6y being equal to 9, of course minus 22. So minus minus will give me plus. So this will be 9 plus 4, I'll get positive 13x. Then of course these two will give me 0 being equal to 9 minus 22, I'll get negative 13. Then of course I'll divide through by negative, that is by, I'll simply, I can rewrite this as 13x being equal to negative 13. Then divided by 13, divided by 13. So of course x will be equivalent to negative 1. Then I'll say substituting x is equals to negative 1 in, let me substitute in my first equation. I'm going to get the following, of course, when I substitute. So remember my first equation was, let me recall my first equation, it is here. My first equation was 3x, then of course plus 2y is equals to 3. So if I substitute, I'll have 3 into my x is negative 1, then plus 2y is equals to 3. So this will be negative 3, then of course plus 2y is equals to positive 3. So this will be 2y is equals to positive 3, then of course plus 3. That is when it crosses equal sign, it becomes a positive. So that 2y is equivalent to 6. Dividing through by 2, 2 and 2 will cancel out, so that y will be equivalent to 3. So it means that the coordinate of S, remember S must be denoted by xy, its coordinate. So S will be given by, our value of x is negative 1, so its coordinates are negative 1, then comma, the y coordinate is 3. Remember, a coordinate must be stated in a horizontal manner, the way I've stated this one here. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kcse Tuition Academy. Thank you very much.